This is problem of IIT 2009, and this is based on fluid mechanics. This type of problem is not asked after that, and I think it may be repeated. Same concept may be repeated this year. The problem is that there is a cylinder of total height 500 millimeter. It is initially open to air, that means it contains some air and it contains some water of unknown height h, and there is a hole at the bottom which is initially kept closed. There is orifice initially closed right at the bottom, and details of water density and atmospheric pressure and G are mentioned here. What is question that if now this upper portion of cylinder is closed, is sealed, and then this orifice is opened, and obviously then some water will come out, and it is seen that when this height of water in the tank remains 200 millimeter, then further onwards there is no flow of water. That means this height remains now permanent. Initially water height was h, that is not known, but finally after this is sealed, upper end is sealed and hole is allowing the water to flow, then finally once water level reaches up to 200 millimeter, this remains constant now. Then obviously there is no flow of water. That means जब ये 200 millimeter हो जाएगा तो water flow बंद हो जाएगा. Based on this information and this information given here about atmospheric pressure, water density and G, what we have to find? We have to find the fall in the height of water level due to opening of orifice. Whatever height was here, from that height up to 200. So what is that fall? That means we have to find basically h minus 200. That has to be an interior answer. And one thing is mentioned here, that air temperature has to be constant and surface tension is negligible, right? Air temperature is constant, it is not mentioned here, I am saying, but we will have to assume, otherwise this problem cannot be solved. Let us learn the concept of this problem. That once we close it, before that air here will be at atmospheric pressure, and by closing there will be no sudden change in pressure, it will be again at atmospheric pressure, and when we open this hole, water will start falling. So initially here is atmospheric pressure, here is atmospheric pressure below the hole, then why water comes out? Due to pressure of liquid. Now as the water comes out, air here will expand because it is sealed now, it has no chance to escape here. Air will expand, and due to expansion of air, pressure in the air will drop. And if pressure is dropped excessively, then it is possible that that lower pressure plus this rho GH of remaining water is just equal to P naught. If so happens that pressure of air plus water pressure is just balanced by P naught, which is atmospheric pressure below the hole, then there will be no flow of water. That can be easily understood by Bernoulli equation, right? If here this pressure plus rho GH is equal to P naught, then there will be no flow of water. So that is the condition we have to apply. And other condition what we should apply, that pressure into volume of air, which is of fixed mass, has to be constant as per Boyle's law. So PV has to be constant, though I think this is not mentioned here that temperature is constant, but in such problem we have to assume, because it is water body and it is large body, so it will keep the temperature constant, and we will have to assume it. So let us assume that final pressure in the air is P, and the volume here is 300, proportion to 300. You can multiply, if assume cross-section area A, you can multiply 300 into A to get volume, but A is irrelevant because finally A cancel हो जाएगा. So we can assume that this volume is proportional to 300. Initially this air volume is proportional to 500 minus h, because total height is 500, this is h. So applying Boyle's law, we can write P naught into 500 minus h, and initial pressure into initial volume of this air equal to final pressure P into final volume, this much. And then apply pressure balance, that since there is now no flow of water in this situation when this height is 200, then pressure of air, this reduced pressure basically, plus rho GH for this height, rho G into H इसको मीटर में कन्वर्ट कर लेंगे, is equal to P naught. Then replace the values of rho, W and G, P naught. We can find the P by solving this equation, because P naught is given in the here, rho is given, so we can find the P. That means final air pressure we can now find numerically. That come out to be this much, 98 into 10 power 3 into square. Replace this value in the equation number 1. We will get H. Let us see how. Then 500 minus H upon 300 will be P by P naught. P we have obtained. P naught is given as 10 power 5. This is 98 into 10 power 3. This is 10 power 5. It will be effectively 98 upon 100 or 49 by 50. So solving it, we get H as 206 millimeter. That means this was initially 206 millimeter and finally it is 200. So we can say by opening of this orifice, water has fallen by height 6 millimeter. So our answer is 6 millimeter. We have to find the fall in the height of water in millimeters. So the answer will be 6 millimeter. It is simple but important concept, and similar concept may be repeated this year.